So, guys, today is the last session of rotation motion. But those who were in a what should I say? Those who were in a confused state or they had the wrong impression. This is not the end of mechanics. Okay, this is not the end of mechanics. Okay, so mechanics will continue to haunt you. We will definitely take a break after this session. I think when we will study gravitation. Gravitation will not feel like mechanics, but we will again come back. Just like IPL took a break in between and it has come back again. As you guys are talking about it in the session, you should not be. We don't care about IPL. Even if you do not care about IPL between 8 o'clock to 10 o'clock. Okay, am I clear? Shall we start? Everybody's ready? Write +1 in the chat box. Yes. If everybody's ready, write +1. Okay, हाँ आज वो होगा. My promise. ठीक है? Some of the students, sir, class पढ़ाओ ही मत, आज वही करो, है ना? Sir, will today's session finish by 9:30? क्यों? आज मेरा birthday थोड़ी है. So today's session will not wrap up at 9:30. Okay? तो चलो भाई, everyone is ready? Let's start. Yes, everyone, let's start. And switching off the chat. And as you know, as always, please do not bother your class teachers with the hi, hello in the doubt panel. You have already wished them. Please do not ask random things in the doubt panel. And if you want to ask doubts to me, please hold on with your doubts. If you think the doubts are very usual, normal doubts, please ask this to your class teachers. If they'll not be able to answer your doubts, they'll pass it on to me. Okay, everyone, starting off. Okay, Vansh will speak at the end. ठीक है, हैप्पी बर्थडे बोल रहे हो मुझे, ठीक है, ओके, गिफ्ट भेज देना, तब मैं बर्थडे विशेस में गिफ्ट के साथ एक्सेप्ट करता हूँ. आई डोंट एक्सेप्ट बर्थडे विशेस लाइक दैट. यस, लाइफ का सिंपल रूल है, ठीक है. Yes, chalo then. Switching off the chat, everybody. You expect return gifts? You're already getting the gift of knowledge from me. Okay. Chalo, awesome. Let's go, guys. Today's session is the last of this chapter, but probably one of the most trickiest one you might find it, because we are going to speak about the dynamics of rotation motion. That means we are going to speak about the force and a little bit of kinetic energy, because kinetic energy I've kind of given you idea in the previous class also. So we'll speak about the kinetic energy and mostly the force and torque during the rolling motion. So we did not speak about these things in the previous class. Now is the time to continue rolling motion discussion. What we did last time was a very plain and simple discussion about rolling motion. We understood that rolling motion is basically a combination of translation and rotation. Okay, so I'll pick that from the same animation that I used last time. Okay, so I'm picking it from there. I hope that it will be visible to all of you. Yes, so this is what we did last time. Okay, should be visible to all of you. This is what in nutshell is rotation plus translation, not visible. This is what happened last time also. My bad, sorry. So we basically understood that if a body is purely translating, then each and every point of the body is moving with the same speed, same velocity, or the same direction, same speed, including the center of the body. But if I try to overlap this motion with rotation, then during rotation, if I talk about different particles, the linear velocity that different particles gain due to the rotation of the body, only pure rotation of the body, you can always trace the velocity vectors. So you can see that the first one is pure translation. You are going to sum it up with pure rotation. So this overall results in rolling. What do we mean by that? The two velocity vectors which are on the top, they will get added together. I did not write the numerical values. Say this is v. Say this is omega r. Obviously, all the particles which are at a distance r from the center will have the same speed. They definitely don't have the same direction. But once you start putting both the first two diagrams over each other, then the topmost point will get a velocity v plus omega r. The bottommost point will get the velocity v minus omega r. Putting it in modulus. Why putting it in modulus? Because depending upon which magnitude is bigger, v or omega r, the velocity direction will be defined. But let me also draw the two vectors. Bottommost point is the most important one. I'll come back to it in some time. But apart from that, if I talk about say center did not get any velocity because of rotation. So only velocity that it gets is because of translation. So this is the velocity of center or center of mass also. Okay, for a uniformly shaped body. This one will get two velocities. You can see that. The other particle will also get two velocity. Not able to draw the complete one. But the most important point, as I spoke about last time also, this gets linear velocity because of translation and gets linear velocity because of rotation also. Don't think that it is omega. It is omega r. Omega r is the linear velocity that body gets because of rotation or because of circular motion, I should say. So these two velocities are very important. So for pure rolling, okay, for pure rolling, we say that if v is equal to omega r for particle p, then we say that pure rolling happens. If any of these is bigger, if v is greater than omega r, translation is more than rotation, or omega r is more than v, rotation is more than translation, it is impure rolling. Okay? And we are discussing, we are more concerned about the pure rolling case. We have to remember v will be equal to omega. That means what? The translational motion velocity and the rotational motion velocity of the circumference particle, they are basically equal in magnitude at least. Okay. And if the body accelerates, then not only v will be equal to omega r, a will also be equal to alpha r, and s will be equal to theta r. Those three conditions of circular motion will be valid here. Okay. I'm hoping everybody remembers this thing. And we also, in addition, what we were supposed to speak today, I have already covered it up in the previous class. That is instantaneous axis of rotation. I explained it to you very much in detail that when the entire body is rolling, when it is rolling and going forward, when this is happening, you can actually make or look at it as a slow motion video of the rolling motion. And the bottommost point, if you focus upon, every instant you will find that the entire body just performs pure rotation about it, which is called as coupling. So the entire body performs pure rotation about the bottommost point. That is what is instantaneous axis of rotation. Today also we will have a brief introduction of that part once again, and we'll actually focus on problem solving after that. So what is our objective today? I'll come back to that part after you solve this one question from the previous class. Then we'll take it at a good speed today. This is a question which is based upon what you just now understood, but the body is not a circular cross-section body. The center of mass is moving with 2 meters per second. The translational velocity, you can say omega is given to you. Question is asking you to find out the magnitude and direction, because plus minus is written. So you can see that because center is moving to the right hand side, that is given as positive direction. So this is positive and this direction is negative. So if you are being asked, you have to find out the velocity of point A and point B. Let's see how many of you will be able to do this, giving you people 60 seconds. Okay, and just to help you out a bit, I am imaginary circle I'm drawing in which the points A and B would be rotating if the body would be only rotating. Okay, just giving you an idea to see, will not keep it there. Okay, so this is what it is, giving you 60 seconds. Time starts in 3, 2, and 1. Think of translation and rotation separately for the body. Means first try to look at the body when it is only translating. Then look at body if it is only rotating about C. Get the two velocities for A and B with direction. Find out the net velocity of A, net velocity of B. Last 30 seconds, everyone. Keep going. That's good. Nice, nice, absolutely nice. Very good. Very nice. Okay. So everyone, see, this is actually very easy to approach if you break down the question into translation and rotation separately. So obviously the easy part is to look at the object when it is translating. So when this thing is only translating like this, so everything moves with the same velocity, and that is the velocity with which center of mass is already given to be moving. So this becomes the velocity with which point A and point B would be moving if it is purely translating. That means this is velocity of translation. Okay. Velocity of translation is given by the center of mass. Okay. So this is 2 meters per second, and the direction is also shown to all of you. Okay, guys. So just writing the numerical value. Now forget about these green vectors. Forget about the green vectors. They are basically because of translation. Now look at C. That is your axis of rotation, and think of the body just rotating about its own position. So if it is rotating about its own position, then particle A will go to the right hand side and particle B will go to the left hand side. That means what? If I locate the velocity because of rotation, that means omega r, the direction of omega r. Blue vector is showing you that. But for B, this is the direction of omega r. And what is the value of omega r? This is, by the way, r. R value is nothing but half of the rod length, that is 2 meters. Okay. So r equal to 2 meters. So omega r comes out to be 5 into 2. That means 10 meters per second. So everyone, look at A. Both the velocity vectors 10 and 2 are in the same direction, while for B, 2 is forward, 10 is backward. So overall, the velocity vector will be 10 minus 2. That is 8 in magnitude, but that direction is negative. So velocity of B is going to be definitely negative, and that's going to be minus 8. But velocity of A is definitely going to be positive, and that is 12. So that is why the correct answer comes out to be option B. You can look at the two vectors once again. B is forward, omega r is backward for B, while the same is both the vectors are in the same direction. Okay, good enough. Yeah. Awesome, everyone. So this is a quick recap of what we did last time. Now let's move on to the important discussion for today, that is dynamics of pure rolling motion. First on the horizontal surface, then on the inclined surface. Inclined surface is going to be the most beautiful discussion that I can expect on rotation motion, and especially rolling motion. You will definitely enjoy this discussion, I'm sure about that. Okay, so let's go forward. Okay, there was one more question also. There was one more question. And make it. Harshita will do at the end. I don't want to disrupt the flow for today. We'll do it at the end. Okay, remind me once again at the end. We'll do it, but not now. Okay, so condition for pure rolling is something that we have already spoken, I think, a lot of times now. When an object, just let's go through that one more time. When the object is rolling on a plane surface without slipping the point of contact, the bottommost point is basically the most important point for us. It should not slide with respect to ground. It should not go forward. It should not go backward. It should remain at rest with respect to ground. So a rolling object whose velocity v is directly related to its angular velocity, this is going to happen, and that relation is also given. I've already spoken a number of times about it. So this will be valid, and not just this. A will also be equal to alpha r, and s will be equal to theta r. These two will also be equally valid. That means what body can accelerate, not that body has to move with a constant velocity. That's what we are trying to say. Okay, in fact, you people must have remembered this also. Okay, we understand this part as well. I told you that when the angle theta is given to us, we can always find the value of velocity for a given point also. Okay, I would not want you people to remember any of this. Why is that so? I'll tell you how they are trying to solve this one. Say the angle between PC and P dash C is given to us as theta. So if you locate the velocity at point, say at point P and at point P dash, they are trying to find out the velocity at point P. So because of translation, this is the velocity, which is V. Only focus on point P. Okay, don't focus on point P dash, because that's the point where right now we are focusing in the question. And this is the velocity because of translation, which we say is omega r. Okay, all of you. Now everyone, I'm going to take this diagram on a bigger scale so that you understand how this is happening, and then we'll come back here. Okay, just because that diagram is there, and I don't want you people to feel that sir is skipping this part. There's nothing actually that I'm skipping here, but let's be very clear with this also. So what is given to us already, that if this is vertical line and this is the line connecting the present point where we are interested in calculating the velocity, then all of you have a look at the direction of its velocity because of translation. This is v, and by the way, this angle is given to us as theta, and velocity because of rotation, which is omega r. Both of them are equal in magnitude. V equal to omega r. But the thing is, what is the angle between these two is what we are interested in finding. So you see that if this angle is theta, this is 90. So we can definitely be sure that if you look at this OP, can you people tell me what is the angle between omega r vector and OP, the line OP? What is this angle? Can you people tell me this angle? No, only this angle. Acha. So what is this angle? This is 90. Then why this is not 90? Can I not say this is also 90? This is the tangential velocity now, omega r. Getting? So this value is 90 degree. Make sense? It's a tangential velocity omega r. Okay, and this angle, this is already 90. This is going to be 90 minus theta. So can you people tell me the angle between vector v and vector omega r? By the way, omega r is also equal to v, magnitude wise. So what is the total angle? 180 minus theta. So everybody, if you have two vectors which are of same magnitude and are inclined at an angle of 180 minus theta, can you not find out? Can we find out the resultant vector? We can, right? By parallelogram law of vector addition. This angle is 180 minus theta. So what is the resultant velocity at p? It's going to be v square plus 2 into v into cos of pi minus theta. And what is cos 180 minus theta? It's minus cos theta, right? So 2v square minus 2v square into cos of theta in under root. That's what it is. So I'm taking 2v square common. I'm left with 1 minus cos theta in under root. This is vp. And for those people who remember this, cos 2x is equal to 2 cos square x minus 1. Okay, or this formula is also 1 minus 2 sine square x. So we can say that sine square x or 2 sine square x is equal to 1 minus cos 2x. Everybody. And what is sine square x then? Right, everyone? So instead of writing 2x, if I write theta, can I say that x will become theta by 2? Instead of writing 2x, if I write theta, then x will be equal to theta by 2, right? So that is what you do. You write it as 2v square into 2 sine square theta by 2. This is what you are using there, okay? And that too in under root. So this becomes 4v square sine square theta by 2 in under root, and you get 2v sine theta by 2. ये अपने आप में एक JE का problem है. This has come as a JE problem many times in different forms, okay? And that is what is done here, by the way. They have found this 2v sine theta by 2. No, please don't memorize the formulas. जब time आएगा physics में तब बताऊंगा, okay? Why was it written VPC? कहाँ लिखा VPC? Are VPC is this line now, P to C, this line. So C is the center of, or rather C is basically the axis of rotation, P is the point whose velocity we are finding. Okay. अमन आदित्य यार कैसी बात कर रहा है, प्योर रोलिंग की कंडीशन है v इक्वल टू ओमेगा r, ठीक है. बाकी डिफरेंट कंडीशंस हैं, आई एम नॉट गेटिंग इनटू दैट. ओके, एब्सोल्युटली बिहान, या तो ये डिराइव करवाएंगे या वैल्यू देके पूछेंगे, फाइंड आउट द वैल्यू of Vp. ठीक है. So my actual point is not to get into this discussion. My objective is actually to take you people to the force, friction force especially. So everybody, now let's talk business. So if we are talking about pure rolling, and that too the pure rolling which is happening on smooth surface. Okay, so we have a smooth surface on which we have a body which is purely rolling. It is purely rolling. Pure rolling means definitely V is equal to omega r. So by pure rolling, we mean that V and omega are constant here, and they are neither increasing nor decreasing. That's what we are meaning here in this particular situation. Okay. So everybody, if this is the situation given to us, this is any body, this could be any object. Okay, V is constant, that is for sure. Can you people tell me what will be the acceleration of the center of mass in this case? Everybody is agreeing to that. That acceleration of center of mass should be zero because velocity of center of mass is constant. Velocity of center of mass is constant. So definitely acceleration of translation is zero because center of mass only translates in this case. Okay. How about angular acceleration then? What about angular acceleration? Definitely zero because alpha is equal to a by r, and that is equal to zero again. So everyone, what would you comment about the net force acting on the body, which means eventually on center of mass, because that is why we study center of mass, so that we can say that entire body is experiencing the same force which I can put on center of mass, and because acceleration of center of mass is zero, that implies that the force acting on the center of mass is also zero. ठीक है everyone. So इकलौता एक force अगर मैं point P पे friction की बात करूं, will it be zero? Will it be not zero? Or can't be predicted? Smooth surface, definitely zero. Definitely zero. Smooth surface. Big question, right everyone? Okay, absolutely. Yes. Point that I want you people to remember from this, that pure rolling is possible on a horizontal surface even if it is smooth surface. Okay. When I say smooth surface, it means ball and the surface on which it is placed both are smooth. Okay. Please remember. But on a smooth surface, friction is zero. If you will apply any force on the ball, if you will apply any additional force on the ball, then pure rolling will not be remaining anymore. Then you will not have any pure rolling left because then center of mass will have another force coming. So acceleration of center of mass will become non-zero. Okay, everyone, getting my point? If I apply a force on this center of mass, say in this direction F, then definitely A will not be equal to zero. Center of mass experiences the force. Then the problem is, if I apply a force on this body when it is on a smooth surface, say I hit it with a bat, horizontally only. Will the friction come into existence because of that? Will I create a friction? No. So definitely friction will remain zero. Friction will remain zero. But the force that I am applying, say if it is passing through the center of mass, it will be able to increase acceleration. It will not be able to increase angular acceleration. Why? Because if you apply the force that you have applied on the center of mass, the force passes through the axis of rotation. If force passes through the axis of rotation, can it generate a torque? It cannot. It can definitely accelerate the body linearly, but it will not be able to increase the angular acceleration because it is not able to generate any torque. So then the body will get into impure rolling. Then translation will be more than rotation. This is what you have to start thinking when you are looking at problems from rolling motion. Okay, everyone. So it is possible for body to purely roll on a surface. It is possible. Okay. Now this is what is even more important. Okay. What if surface is rough? Still pure rolling can happen. Okay. Or rather still pure rolling is happening. That's what the situation is saying. Okay. Yes, Akul, that's what it is. So question, now the situation says that surface is rough. When we say surface is rough, then that means the body and the ground surface, both of them are creating some friction. Okay, or they can create a friction. I'm not saying they are going to create a friction, they can create a friction. Okay, so situation says that you have still some pure rolling happening. I've said surface is rough. I have not said there is friction. Please remember. So I'm not the one who will answer it. You will answer it. So still pure rolling is happening, but acceleration of the center of mass is zero. It is still velocity being constant. So my question is, if velocity of the center of mass is still constant, what will you comment about the first of all the friction? Can we say that in this case also the friction will have to be zero, right? Everyone, has to be zero. Okay. Good. Acha, just before I explain this is not the answer, by the way. The friction force at P is not equal to zero. That is what makes the situation even more awesome and tricky. So people, do you remember from friction, if I have a block on which I'm trying to push a block, but it is not moving. I'm trying to push a block, it is not moving. What is the nature of the friction that comes into existence there? And what is the net force acting on the body? In that case is zero, definitely zero. Now everybody, pay attention to this. If I speak about this situation, let's focus on the bottommost point. This is the bottommost point which makes or breaks pure rolling condition. Do you all remember that? It is the bottommost point which makes or breaks the bottommost point, the most important point. Okay. When we say that bottommost point does not slip with respect to ground, so what can I comment about the type of friction which possibly should be there? Can I say static friction? For sure. So guys, at the bottommost point, you will have static friction acting. In that case, and you know that static friction will not be able to increase or decrease the velocity of the body. Body is definitely moving. Yeah, it is rolling. V is equal to omega. This is all valid. But all of you, what I'm trying to make you people understand, the bottommost point has which force acting on it? Which force? Static friction is acting on it. And when static friction acts on the body, what we comment about the state of the body's acceleration? What will be the body's nature in that case? It will be in equilibrium. That means what, guys? If we look at the static friction situation here, the static friction will act on the body and it will try to act in a direction which can justify possibly, which can justify if there is a possibility of any other force acting on it. If there is any other force acting on it. Okay. So guys, coming back to the situation, how do I judge whether there is right now a force acting or there is another force not acting or acting at the moment? So now justifying and clarifying the two situations when this condition is given in front of you, there are two possibilities. The first possibility where we all answered, if the surface is rough, the friction should be zero if velocity is constant. That is going to be true. I'm dividing this condition into two parts so that no confusion stays. I'm going to split it into two parts, part one and part two. Please focus completely on the screen, and I'm switching off the chart so that we all understand this better. This is situation one. Situation one is, let me just check if that situation is already going to come later on. That situation is going to come. Sorry. I have kept it later on. So I'm going to come to that part. Let's keep it very simple, very easy then. The situation 2 is anyway waiting for us. I forgot that I've kept it forward. Guys, very simple situation as we started with it. What will say if the net acceleration of the center of mass is 0? Can I say that the net force acting on the center of mass should also be 0? Explanation that's my part. Anyway, right now the acceleration of center of mass is 0. So we can say that the net force acting on the center of mass is 0. So the net force acting on the center of mass is still 0. And what will I comment about the friction also, including the net force should also be 0 because you have not applied any external force on the body. So even if the surface is rough, everyone, even if the surface is rough and the body is not accelerating but is purely rolling, then also the force acting on the body, friction force especially, will remain 0. Not even static friction will act here. Why? Let me justify that. Why static friction will not be valid here, will not be acting here. So everyone, if I first of all apply a static friction force, say at point B like this. First of all, this tells us that there is one force acting on the body. As a whole, there is one force acting on the body. So that will invalidate this condition first of all. That is one hint. Second hint, all of you, about the axis of rotation. Can you see that there are two more forces acting on the body, by the way? Mg and normal force. Those two forces are always there, but they cannot rotate the body. Do you agree? Right now, if I start keeping this bottle like this, there is Mg which is acting downward, there is normal which is acting upward, but they cannot rotate the body. They cannot. So I'm talking about the static friction or any possible friction. Do you see that this friction can try to rotate the body in clockwise sense? R cross F, right? But if that happens, that will mean that the torque will be non-zero. And if torque will be non-zero, then angular acceleration will be non-zero. And if angular acceleration becomes non-zero, the entire condition gets violated. Are you all with me? Do you all understand this? Okay, this is simple, very simple. What you have to go by is the natural understanding of NLM, laws of motion. Okay, it is not ideal condition, it is practical condition. Nothing ideal here. This is practical which will happen on the body. Okay, if a body is purely rolling on a surface which is rough, it will not have any friction force acting if there is no external force acting on it. Okay, now everybody, say there is acceleration also happening. That means what? You have applied an external force also. So the bottom line was that there was no force acting in the previous case, even when the surface was rough. Okay, now everyone, come to this one. Say you have a solid sphere whose mass is m, okay, whose radius is r, and it is purely rolling, and now you have applied a force like this. You have applied a force on the center. The surface is now rough, everyone. If the surface is now rough and you have applied a force here, okay, so this time question is asking us to find out the value of acceleration of the body, which is basically the acceleration of the center of mass. Is what the question wants us to find out. So you all see the axis of rotation, all of you. That's basically the center of mass only. That's the axis of rotation. Okay. So now, before I even think about finding the acceleration, finding or drawing the free body diagram, there are two questions which I will ask myself. Those are written on the screen already. Listen to me and try to think about it first. How do I decide if friction is acting or not? Because sir, in the previous case you said even when the friction, even if the surface is rough, the friction was 0. Now also the surface is rough. Okay, it is rough surface only. So surface is rough. Will the friction be acting or not acting at point B? That's first question that I should be asking myself. Okay. So let's try to answer that part. If friction will be acting or will it not be acting? Okay, everyone. We see that the force which is acting on the body is acting, say, on the center of mass. So can I say that definitely the center of mass has a possibility of having an acceleration which is not 0? Okay, everyone. And if acceleration of the center of mass is not 0, that means its velocity is definitely going to increase. It's definitely going to increase. I'm trying to answer the first question right now. Okay, very good. If I want the body to purely roll, can I say that because in pure rolling, we should always be equal to omega r. So this condition will only hold true if velocity is increasing, angular velocity should also increase. Then only we will be equal to omega r. Do you logically understand this? That means what? If the body tries to speed up, it will also have to speed up its rotation. It will also have to speed up its rotation. Then only pure rolling will be valid. Okay, because r is something which is constant. Radius of the body is not changing. If v is increasing, omega has to increase in order to keep the body in pure rolling. But my question is, guys, if omega has to increase, then definitely alpha should also be non-zero. That means then the body should have angular acceleration if angular velocity is increasing. But if the force is acting on the center of mass, will it be able to generate any torque? Will this force be able to generate any torque? No. Now read the question, the first question here. Will friction act or not? Should friction act or not? It has to act so that it can provide that torque. So that it can provide that torque. Are you getting? Now tell me, what will be the direction of the force of friction? Achha, first of all, before we talk about the direction, what will be the nature of the friction? Kinetic or static? Kinetic or that's a very important question, by the way. Kinetic or static? For pure rolling, what have I said about point P? Should it slide or should it remain at rest? Point P, the most important point in rolling. Should it slide or should it remain at rest? It should always remain at rest. And if it remains at rest, what should be the nature of the force of friction? Remember, all of you, remember, this is the most important point about the rolling when friction is acting on a body which is purely rolling. Okay, is it limiting or not? That is different. It can be limiting also, but it is definitely static because limiting is only the maximum value of static. But what is important? That the body at point B is not sliding. Okay, guys. Now, because the body, according to this diagram, is going to rotate in a clockwise manner, just do hit and trial. Just do hit and trial for the direction of friction. If you apply the force of friction like this, will it work? If pure rolling has to happen, force of friction has to be static. That's what I'm saying. You guys see that this will not be able to generate a clockwise torque. This will be able to generate an anti-clockwise torque. So that's not going to be the direction. Do you agree, all of you? So this is going to be the direction of force of friction. So do we have the answer of both the questions now? What is the direction? Backwards. Is it acting? Yes, it is acting. Okay, everybody, but we are only halfway there. We have to still solve the question. How will we solve the question? Because the body is, we can't say anti-clockwise, doesn't. The body is going to move clockwise only if it is moving forward. That's how the natural rolling will happen, right? If you throw a body which will roll, this is how the rolling will happen. Body going forward and clockwise rotation. That's why. Okay. So everyone, whenever you have to solve questions, okay, I'm also answering about friction only, Krishna. Friction is force, not torque. Friction जो torque लगाएगा वो clockwise है. Friction is a force. Friction is not a torque. Okay. So all of you, because rolling is combination of rotation plus translation. So let's write the equation of translation. We are sure that this body, which is a solid sphere, it is accelerating and it is angularly accelerating also. So can I say that in the horizontal direction, F minus static friction should be equal to mass into acceleration? बचपन वाली equation है तो ये laws of motion यही होनी चाहिए. Forward force minus backward force is equal to mass into acceleration. This is called equation of translation. This is dynamics that you are studying. That means force you are studying. Now let's write tau equal to I alpha. Which force is going to generate the torque? Can capital F generate a torque? Quickly in the chat box. Capital F cannot generate any torque because it is passing through the axis of rotation. So I can say that static friction acting at a distance of capital R. This angle is already 90 degree, right everyone? So it is F into R into sine 90 degree. I've already written that. Should be equal to I alpha. Directly लिखूं 2 by 5 mr square into alpha. Okay. Or if I write it as 2 by 5, let it be for people who might ask me this question later on. It is I alpha written. I will be written as 2 by 5 mr square. And how can I write alpha if it is pure rolling? Can I write this? That alpha will be equal to A by R because it is purely rolling. So I'm writing it as A by R. Why am I writing it like this? Because the question wants me to find out A. It wants me to find out A only. If it would be asking me alpha, I would replace A in form of alpha. Or maybe I calculate alpha, then later on I'll write finally as alpha R and solve this. So guys, see, R cancels one R, another R cancels another R. Do you see that all R gets cancelled together? Do you see that? So eventually I get the equation of static friction as 2 by 5 ma. Now this is the equation of rotation. Actually the first one was the equation of rotation, but this is your equation number 1. This is your equation number 2. Can you solve these two equations? There are two unknowns, you need only one unknown. That is A. Okay. Is that clear? All of you? Cool. So we'll put this value, ek to tarika we can put this value here, or the other method is to simply solve these two equations. F minus Fs is equal to ma, and just cancelling all these values, R ko gayab kar diya maine. Okay, everyone, you see when I add these two equations, Fs gets cancelled, capital F comes out to be ma plus 2 by 5 ma comes out to be 7 by 5 ma, A comes out to be 5 by 7 F by m. Can I calculate the value of friction also, which is acting on the body? Can I calculate the value of friction? Yes, I can. Friction force is 2 by 5 mass into acceleration. So 2 by 5 m, acceleration is 5 by 7 F by m. You see that 5 and 5 cancels, m and m cancels. It is 2 by 7 times of F. It is 2 by 7 times of F. Now those people who are asking, sir, is this friction limiting or is this friction less than limiting? Now you can check if the value of mu is given to me. If the value of mu s is given to me, I can calculate the limiting friction, which is mu s into n or mu s into mg. If this value, definitely you see that it is dependent on mu s value. If mu s mg value comes out to be equal to this, if mu s mg comes out to be equal to this, then it is limiting friction. But if this value comes out to be greater than this, then it is only static friction which is acting at the moment. Okay, all of you. And I have calculated the answer in terms of capital F. If you will see, if capital F is constant, friction is constant. If capital F is increasing, friction will increase. If capital F is decreasing, friction will decrease. Okay, I've answered that, Nishchal, just now. Everyone, this is one example to clarify entire rolling on horizontal surface, by the way. You should definitely watch the replay of previous half an hour. Okay, you will understand how friction plays that role. Okay, good enough. See, entire mechanics being used. Just one example. Almost entire mechanics got used. If I will make the force variable, I can actually bring calculus also into the picture. अगर force variable हो capital F, तो friction इसी में you will have calculus also coming into existence. ठीक है, चलें कुछ questions करें. It's been almost an hour. I did not even realize. It's almost an hour. Let's go and do some problems. Because we have to actually see something even more amazing than this. That is rolling on an inclined plane. एक body inclined plane पे roll होते हुए नीचे ऊपर जाएगी. So we'll see about that. Yes. Don't worry. The build-up is always slow, but then we actually gain that momentum and we'll go fast. Yes. Sure then. Question for all of you. Very interesting question. I've already written that. And there is a challenge also. I've made a challenge for all of you. Okay. More than 50% people will definitely answer this incorrectly. Definitely more than 50%. Okay. Question. There's a disc. Okay. It's a disc which is basically, you know how the disc looks like. So this is basically a disc. Okay. And this is performing a pure rolling on a smooth horizontal surface. It's going like this. Okay. And as shown in figure, at any instant, the lowest point, the lowermost point here of the disc, what will you comment about it? What is definitely told to you that it is moving with a constant angular velocity. That means v is also constant. I am giving you this extra help. This v by r, which is omega, is also constant. This is clearly given in the situation. So what will you comment about the bottommost point, about its velocity, about its acceleration? Okay, giving you guys 45 seconds, and the time starts in 3, 2, and 1. Let's see if you guys defeat me in this challenge or you all get defeated together. Okay, everyone, and the time is up. Let's see Who wins the challenge? Me or you guys? This is interesting. Told you guys. Told you. There's like 80% people answering it incorrectly. Okay. ठीक है तो चलो आप समझ लेते हैं कि ऐसा क्यों है. Look at the options यार. Look at the options. Look at the option. Can I say definitely point P has no acceleration in this direction? Definitely does not have any acceleration in the translational direction, right? But do you agree that it is rotation plus translation which is rolling? It is rotation plus translation which is rolling, correct? So can I say that if I only look at the rotation part of this motion, point P is also moving in a circle. Point P is also part of that circle. Do you agree? So definitely because of the velocity that it gains, okay, because of the rotational velocity that it gains, it has a centripetal acceleration. Yes. And when you look at the option, I was actually worried that some of you will definitely crack this by looking at the option. V square by r is given. V square by r. Centripetal acceleration to hoga na. Its tangential acceleration will be 0. Definitely. Tangential acceleration is 0. Okay. And point P, what is its net velocity? What is the net velocity of point P? It is 0. Absolutely. The net velocity of point P is 0, no doubt, but it has centripetal acceleration. यार अब तुम बार-बार मुझसे वही सवाल पूछोगे. Pure rolling है. It is pure rolling. Point P does not move. It does not move. But it is a part of that entire body. That's why. Okay. That's why the correct answer. Velocity is 0, but acceleration is centripetal. V square by r. Chalo, everyone, quickly moving on. This time again, now this is something that I have given you the entire last half an hour for. When the body has a force acting on the center of mass, coefficient of friction is also given to you. Mass of the body is given to you. The force which is acting on the body, its value is given to you, and radius is not given. You can assume it to be capital R. Okay, so you have to find out the value of the friction force. Okay, I will help you out with one thing, that because the force is acting on the center of mass, it will not be able to rotate the body, so the friction is going to act in the opposite direction like this, and that is going to be a static friction. इतनी मैं help करता हूँ. अब तुम्हें पता लगाना है what is the value of the static friction. Giving you all 90 seconds only, and the time starts in 3, 2, and 1. It is entirely the same question which I have explained it to you a few slides back. $25 seconds remaining, everyone. Okay, and time's up. Very good, awesome. तुम लोगों ने वहाँ फॉर्मूला नोट डाउन कर लिया था, मुझे पता है. तुम सबने वहाँ फॉर्मूला नोट डाउन कर लिया था, वैल्यू पुट किया. I know you guys. I know you guys. I know that. I know all of you. I know you very well. So you see, guys, 2/7f is the answer. Yes, I know you all. और ऑब्जेक्ट मतलब तुम्हारी किस्मत इतनी अच्छी है कि ऑब्जेक्ट भी सॉलिड स्फीयर है. What is wrong in that? Actually, nothing is wrong in that. अच्छा हम यहाँ चेक कर सकते हैं, is it limiting or static? Is it limiting or not limiting? Let's check it. Okay, mu s mg का वैल्यू चेक कर लेते हैं. Mu s is 1/10, mass of the body is 10, and g value is also 10. So the value of limiting friction is 10 Newton. So what is the nature of the friction currently in the situation? It is static and not limiting. Definitely, you can see that it is less than limiting friction. Good, awesome, very nice. चलो अभी quickly ये सबको याद आ गया. सबको याद है, those who were there in my previous class, instantaneous axis of rotation. So when the entire body is rotating with an angular velocity about c, you can actually consider point P as the instantaneous axis of rotation, and the entire body performs pure rotation. So you can say this is pure rolling. This is pure rotation. But look at the shift in the axis of rotation. Yes. ठीक है? हाँ, जो मेरा stunt video तुमने देखा था. Exactly. So that is what it is. And I told you what is the benefit here. When I will try to write the kinetic energy in the first case, I'll have to write down half mv square plus half IC omega square. IC, because axis of rotation is passing through C. But here, if I want to write down the same value of kinetic energy should come, but that will be half IP omega square. And how will I calculate IP? By using parallel axis theorem. Absolutely, yes, yes, Aditya Rana, exactly the same. ICOM plus MR square, correct. And that's what is done here. You can see this. So this is when the situation is rotation plus translation, and this when the situation is pure rotation about instantaneous axis of rotation. Should we jump to problem solving? Should we go to problem solving? So I'll explain you guys an example, then you guys will try a question. Like this one, guys. You see that you have a force F which is applied on the top of a ring, and mass M and radius R placed on a rough horizontal surface as shown in the figure. This time the force is not even acting on the center of mass; it is acting at the topmost point. This is actually the situation that you might have seen. You might have done it by yourself also. If you take a tire and if you take a stick and you start pushing it on the top, means what? This is the tire, and if you start doing this, the tire starts to roll. That's what it is. Okay. So friction is sufficient to prevent slipping. That means question says that V is equal to omega R is valid, A equal to alpha R is also valid. So the friction acting on the ring will be how much, and what will be the direction is what question wants you to find out. So say the friction assumed that it is acting on the forward direction. I say it is assumed on the forward direction. So if I consider point P as the axis of rotation, instantaneous axis of rotation, then the torque due to friction, okay, about P, torque due to friction will become 0, right? Because the force is passing through that point. Mg and normal are already passing through P also, because this is what is the direction of Mg, this is the direction of normal, so they are useless forces when it comes to torque in this situation as well. So the only force which is not passing through this point P is force capital F. The only force which is not passing through point P is passing through the topmost point. Okay, so I can say that now this force is acting at a distance 2r, So the torque becomes F into 2r. Force into distance from axis of rotation. Angle between these two is already 90 degrees. So sin 90 becomes 1 already. And the moment of inertia of the ring about point P. So about center of mass, the moment of inertia for a ring is mr square. And about P, I have to add md square. D is equal to, or rather this distance, small d, is equal to the radius of the object. So the moment of inertia becomes 2mr square by parallel axis theorem. Now you see that 2 cancels, r cancels, I have F by mr as the angular acceleration. Okay. If I also write F plus F equal to ma, which is basically the net force acting equal to mass into acceleration, I can write A as alpha r. Okay. And when we simplify these two equations, we are going to get the value as friction the value equal to 0. Why we are going to get that is because from here, if I write this alpha as A by r, you see that this gets cancelled. I get capital F as ma. If capital F is the only force which is generating the entire ma force, then definitely the force of friction has to be equal to 0. So in this case, in this particular case, the answer comes out to be force of friction to be equal to 0. Okay, guys, this is how the situation is simplified by talking about the instantaneous axis of rotation. Okay, friction is not in forward direction. Friction is actually 0. It is assumed to be in the forward direction. Okay, all of you understand? Friction is assumed to be in the forward direction. It is not. Friction का direction नहीं है, friction 0 है. So answer will be unchanged if I take the direction of friction opposite. Okay? Yes. Good enough. Now a question for all of you guys to try, and you have actually solved this question with me. This is basically a cubical block moving on a smooth surface. This cubical block will hit this point O. When this hits this point O, what will happen with it? It will topple. It is going to topple, right? I have already given you the moment of inertia of the body about its center of mass. So you have to find out the angular speed of the block after it hits point O. After it hits point O. So point O is basically the instantaneous axis of rotation for the entire body when it is going to topple about it. You have to find out the value of its angular velocity about this. Am I clear? This is center of mass. This is your axis of rotation. I can tell you this distance also, but I'm not going to tell you this distance. Okay. Okay. I've given you the moment of inertia about C already. About center of mass, the moment of inertia is 1 by 6 ma square. Giving you guys 60 seconds and 90 seconds. And the time starts in 3, 2, and 1. We have done this question. I'm not even saying we have, this is a new, we have done this question. There is one more concept which is involved here which I have not spoken about today. Let's see how many of you remember that. Come on, everyone. Time's up. Let's see. This is a real easy one, yeah. This is a real easy one, actually. Remember this, everyone. First, you will focus on the center of mass, which is moving at a distance a by 2 from the. Remember, angular momentum conservation. We have done this question. So earlier, center of mass is the only thing which is moving. Yes. So m into v into d. This is written as d, mvd for body which is moving in a straight line, equated to the value I naught omega. So about O, center of mass ka moment of inertia which I've given you guys 1 by 6 ma square add mr square. R value is something that you had to figure out. That was the only part you were supposed to figure out by yourself. A by root 2. Square that value, put it here, 2 by 3 ma square, and this is equal to mv a by 2. Simplified, a and a gets cancelled, m and m gets cancelled, omega comes out to be 3 by 4 v by a. That's it. Okay. Chalo. Now let's speak about the last one and the most important and most interesting condition of pure rolling. Now the body will purely roll on inclined surface, and this is a very interesting situation. So I hope you people remember I have said this, that pure rolling is possible on a smooth horizontal surface. Means even if the surface is smooth, but it is horizontal, pure rolling is possible. V can be equal to omega. Okay. Now when we'll speak about the pure rolling condition for inclined plane, let me state it in the beginning only. Pure rolling is not possible on a smooth inclined surface. Not even in an ideal world. Not even in an ideal world it is possible. You require force of friction for pure rolling on an inclined plane. Please remember this. Okay. How is what I'm going to prove. Okay. So everybody have a look at this. The usual condition. You can see mg acting, you can see normal acting. I have already said that it is purely rolling, so definitely alpha will be equal to a by r, and say moment of inertia of the body is mk square. Okay, everybody's okay with it? Everybody understands? So far the diagram is clear to you? Good. Now we have to figure out whether friction will act or not. I'm saying if friction does not act, what will happen? Say if surface is smooth. If surface is smooth, even Rajnikant cannot bring a friction here if the surface is smooth. So say friction is 0. So can I say that I'll have to resolve mg into 2 directions? All of you remember this? This angle will be theta. You will say this is mg sin theta. This is mg cos theta. So everyone sees this? Everybody? Now look at this. Can you see that normal will be balancing mg cos theta in fact, correct? But mg sin theta will be equal to ma, correct all of you? So what is the linear acceleration? Quickly, मजाक नहीं, serious बात कर रहा हूँ. I'm very serious right now. Okay, a equal to g sin theta, याद आ गया? Laws of motion, right? But if a is equal to g sin theta and that is definitely not equal to 0, we definitely want alpha should also not be equal to 0. This is the requirement then. Why? Because alpha has to be equal to a by r, and if alpha increases, sorry, if a increases, alpha has to increase. It has no choice. But now do you see both these forces, normal and mg, which of them will make this possible? For alpha to be non-zero, torque should be non-zero. In दोनों में से किसी force के लिए possible नहीं है. Both the forces are useless when it comes to torque. Do you agree and do you understand, all of you? These two forces are passing through the axis of rotation. They are passing through the center of mass. They cannot rotate the body. And if they cannot rotate the body, the condition violates. Pure rolling not possible. Okay, writing it here. Okay, but mg and n are passing through AOR, so cannot provide torque, hence pure rolling not possible in the absence of friction. Okay, लिख दिया. For those who are not able to understand my words, written the words. Good. So this is basically, yes, translation will be more than rotation. So impure rolling हो जाएगा. So do we agree? Friction has to be there. Friction has to be there. Now let's figure out the direction of friction. Definitely in this case, the body is going to rotate clockwise in order to cope up with the translation, right? And then can I say that the friction has to act backwards? This is the realistic scenario, even in the ideal case. Okay. So you all now see this absolutely clear. So this is the direction of friction, so that the body can have a torque. So now I will say that mg sine theta minus friction, and obviously which friction? What type of friction? Static. Has to be static because point P cannot move. Has to be a static friction. ये तो मतलब this is like word written on a stone. You cannot just change it. Carved already. Okay. So mg sine theta minus static friction should be equal to mass into acceleration. Alpha is equal to a by r. We are interested in calculating the linear acceleration. Now let's write torque. Static friction multiplied by r should be equal to I into alpha. Alpha I'm writing as a by r. So do you see that static friction can be written as I a by r square? लिख सकते हैं? हाँ यार कितनी बार repeat करूँ ये line? कितनी बार? How many times? This is, remember this. Okay. Let it be there for 1 minute so that everyone who may have this doubt coming in future will remember this. Okay. Now people, one thing is you can actually take this and put it here. So चलो वैसे कर लेते हैं. I don't like that method, but चलो वैसे करते हैं. mg sin theta minus ia by r square should be equal to ma. Taking this now right hand side, so mg sin theta is equal to m plus I by r square into a. Okay, good enough. So acceleration comes out to be m. एक काम और कर लेता हूँ मैं m common ले लेता हूँ. If I take m common, I'll have 1 plus I by mr square into a. You can multiply this m back inside and see if this comes back to this equation or not. Okay, इससे benefit क्या होगा? इससे benefit ये है that I can cancel m here with this one. Right? Perfect. So a comes out to be g sine theta divided by 1 plus I by mr square. Okay. Now it's not as simple as that. Driving minus opposing वाला नहीं है ये. ठीक है? If the body is not rolling, if it is not rotating at all, then I will become 0. Answer will become g sine theta. Pure translation. Okay. Clear? Hence proved that pure rolling is possible on an inclined plane only if it is rough. Okay. चलें कुछ क्वेश्चन देखें. Theory is done by the way. We're done with theory. चलो questions. First question is an example. A uniform solid disc rolling down an incline making an angle theta with the horizontal, the minimum coefficient of friction required to maintain pure rolling motion for the disc. Okay, so we have already got the acceleration value. Okay, so if you get the value of acceleration as g sine theta upon 1 plus I by mr square. So for a disc, the moment of inertia about its center of mass perpendicular to the plane, that means this type of rotation, and about this axis of rotation, the moment of inertia is half mr square. Okay, so I ka value is half mr square. That means I by mr square is half. That means g sine theta 1 plus half mr square by mr square cancels. We get it as 2 by 3 g sine theta. That's acceleration, not the answer. Okay. Now, how do I calculate the force of friction? Let me take you back there so that we understand this. Friction force was Ia by r square. Ia by r square. That's basically the force of friction. Ia by r square. So moment of inertia is half mr square by r square. Acceleration is 2 by 3 g sine theta. Not getting into writing all the equations once again because that is going to be a repetitive thing. You see that r square gets cancelled. Secondly, 2 and 2 gets cancelled. The final answer is going to be, rather this is also friction, that is coming out to be 1 by 3 g sine theta. Sorry, 1 by 3 mg sine theta is what I'm getting. ये आएगा everyone, friction का value ये आ रहा है, ठीक है? And if I equate it to be mu s into mg, the normal force, mu s into mg cos theta, my bad, mu s into mg cos theta. क्यों है ऐसा? वो भी देख लो. What normal is balancing? Normal is balancing mg cos theta, not mg. अगर mg को balance करेगा तो horizontal surface हो जाएगी. So that's why. What do I see? mg and mg cancels. Mu s comes out to be tan theta by 3. Everyone gets it? Next step, tan theta by 3. That means answer is option B. ठीक है? Great, awesome. So that's our answer. Another one. I think I have to make it a quiz. मैंने लिखा नहीं है. When a body rolls without sliding up an inclined plane, the friction force is. चलो quiz नहीं ले रहा हूँ, इसको explain करता हूँ. Wrong tag in the previous one. अच्छा हाँ, this is incorrectly tagged. 1 by 3 आना चाहिए हाँ. This should be 1 by 3. Mistake in the slide. Wrong mistake in the slide. ठीक है? मैंने submit किया, तुम लोग भी submit कर देना. ठीक है? Yes. So guys, now this one, pay attention to this. Pay again. When a body rolls without sliding on an inclined plane, the friction force is directed up the plane, directed down the plane, zero, or dependent on its velocity. So have a look at the solution directly. You see that when when a body will be rolled up an inclined plane, means you are going to do this. You are going to actually roll it up like this. You are going to actually give it some velocity. Means what? Maybe you have an inclined surface, a road, and you take a tire and you throw it up. Throw as in you slide it up. It starts rolling and it goes up. This is how the rolling will look like. All of you see that? This is how it's going to roll down. Okay. Now you see that everybody, it says it has given us the direction of angular rotation, or rather its rotation is given correctly. The body is going up, it is clockwise rotating, but the direction of angular acceleration is opposite. Why? It is going up. Its rotation is clockwise going up, but why angular acceleration is opposite? Yes, everyone, because it is retarding, and we are sure that its velocity is decreasing because it is going up now. It is not acceleration, it is retardation. So this thing is retardation. So that is why it has to oppose the direction of angular velocity. It has to oppose the direction of angular velocity. So the torque will be provided by the force of friction. The torque will be provided by the force of friction, and that too you have to provide torque which is equal to I alpha. So if alpha is anti-clockwise, if it is anti-clockwise, torque also has to be anti-clockwise. We know this, right? So direction of force of friction, can I say, has to be here? All of you agree? This is when friction will be able to provide a anti-clockwise torque. Interesting. ये सारी चीजें मैं समझा सकता हूँ. Actually, you have to just understand it. Yes. I think one more example. This one is something that you will solve. You will solve this. Three bodies. Friction is opposite to the motion, but not opposite to the motion of the body. It is opposite to the relative motion. और यहाँ तो static friction है, मोनीश. वो गलत concept सीख लिया तुमने कहीं से. Friction is not opposite to the direction of motion. इसका मैंने बहुत beautiful example लिया था when I taught you friction. Yes, friction is not opposite to the motion. Never. We don't say that. Anyway, three bodies. One is solid cylinder, whose moment of inertia is half mr square. Another is solid sphere, whose moment of inertia is 2 by 5 mr square. And third one, where is the third body? A ring. A ring is also there. Third body is a ring. Okay. Whose moment of inertia is mr square. That's the third body. Hidden body it is. Okay. So they start from rest and they roll down the inclined plane. I don't want to break this. So this will come down like this. Roll down. Okay. So when they are rolling down an inclined plane, all three of them with the same inclination, they come down an inclined plane. Question is asking us, okay, when they reach the bottom here, when they reach by traveling the same distance, they start with zero velocity. They definitely have some final velocity. Which one of them will reach with the maximum velocity? Which one will reach with the maximum velocity? Do you guys want to try this? You've already started answering. So I'm going to create a quiz here. Let's see how many of you will be able to get this. I'll give you guys 2 minutes, by the way. Starting the quiz in 3, 2, and 1. In this one, you will require law of conservation of energy because it is pure rolling. Static friction cannot increase or decrease the kinetic energy because it is static friction. It is kinetic friction which changes the mechanical energy. Static friction does not. So simply you can apply law of conservation of energy at the highest point and at the bottommost point. So try to find your answer in terms of I, and then you know the moment of inertia of the three bodies. Then check out. Kinetic energy at the bottommost point will be half mv square plus half I omega square, and at the topmost point they all have the same potential energy mgh. They have the same potential energy mgh. But at the bottom, because they don't have same moment of inertia, they will not have the same kinetic energy. Half I omega square will play the game. If this would be a question from laws of motion where a body is sliding down, answer is option D. If it would be sliding, but the body is not sliding anymore, it's rolling down. Last 40 seconds, everyone. Even if you get in the right direction, even if you get the answer of final velocity expression in terms of I, moment of inertia, you should consider yourself to have done it correctly. Okay, all of you. Okay, time's up. That's much better, by the way. That's much better, all of you. You see that mgh equal to half mv square plus half I omega square. Moment of inertia भी लिख सकते हो या फिर in terms of k. K is what? What's k? What's small k here? Small k क्या है? अच्छा, if you did by this also, then that is also commendable, by the way. Those who did by acceleration, Karthik and all. आता हूँ उस पे भी आता हूँ, पहले ये वाला बता देता हूँ. So everyone, k is radius of gyration. Okay. So now you see that m gets cancelled. V comes out to be 2gh upon 1 plus k square by r square and under root. We know the value of moment of inertia, so k square by r square values for ring we can find out. For solid cylinder also we know. For solid sphere also we know. So when you will simplify this, guys, you will get that the body which will reach with the maximum velocity. If you look at the expression also, guys, for the body for which denominator will be minimum, for which the denominator is minimum, will have the maximum velocity. Do we agree? Yeah, you can say that whose moment of inertia will be more will have the minimum velocity, definitely. So can whose moment of inertia will be more with the maximum velocity will have the minimum velocity here. Okay, I by r square. मैं खुद कंफ्यूज हो गया, मैंने क्या बोला? K by r square का वैल्यू जिसका मिनिमम होगा उसकी वेलोसिटी मैक्सिमम होगी यार, उल्टा बोल दिया हमने. Just a second. So for the ring, the value of v square for the ring comes out to be 2gh upon 1 plus 1. That is 2gh by 2. That's for ring. Okay, under root of gh. मैं इसको लिखूंगा under root of 2gh by 2. And for the cylinder, it is under root of 2gh by 3 by 2. That means it is under root of 2gh by 1.5. So you are dividing with a smaller value. So definitely v cylinder is more than v ring. And for the sphere, That's going to be 2gh upon 1 plus 2 by 5. That comes out to be under root of 2gh upon 1.4. So definitely the denominator is minimum for sphere. Answer is right. Everyone gets it? The minimum value of denominator is for sphere, so velocity of sphere will be maximum. Correct? Yes. Also, if you would have done this by g sine theta upon 1 plus I by mr square, so whose moment of inertia, have a look, whose moment of inertia is going to be maximum, that will have the minimum value of this. जिसका moment of inertia minimum आएगा, उसके लिए denominator minimum आएगा, and for that the acceleration will be maximum. So do you see that moment of inertia is minimum for solid sphere, 2 by 5 mr square. Get it? 2 by 5 mr square. That's the minimum value. So acceleration of solid sphere is maximum. So definitely its velocity will also be maximum after traveling the same distance. Okay. Chalo everybody. One more question. That's a quiz question for all of you. That is based upon acceleration itself. The rolling object rolls without slipping. That means pure rolling down an inclined plane. Angle of inclination is theta. Then the minimum acceleration it can have is how much? What is the minimum value possible for this acceleration? Whatever be the object, what is the minimum possible value? Giving you guys 45 seconds, and the time starts in 3, 2, and 1. Come on, everybody. Nice. Okay. This would have been better actually. What is the minimum value that I can, or what is the minimum expression of moment of inertia? Ulta. We want the minimum value of acceleration. So we want the maximum value here. You want the maximum value in the denominator. And maximum value is mr square. Every other value is lesser than mr square. Right? So I max is mr square. Right, everyone? So maximum value that you can put for moment of inertia is mr square. And for that, mr square by mr square is 1. 1 plus 1 is 2. So g sine theta by 2. That's the answer. Okay. So a few miscellaneous questions. These are not only from rolling, these are general questions. Question says that you have a rod, that rod was vertical, and if it starts falling like this, the axis of rotation is there. Question is asking you to find out that if this starts to topple, when this is going to become vertical, when this will become vertical to horizontal, the rod, then the velocity of the point B, this point B, what will be the velocity of this point? Okay, no comments. I will not comment upon anything. Okay, giving you guys complete 90 seconds to think about it. Only thing that I can tell you is moment of inertia of the rod about A is 1 by 3 ml square, and your time for 90 seconds starts in 3, 2, and 1. Okay, that's good. That's nice, all of you. So yeah, actually, बहुत simple था. Law of conservation of energy था ये. This was only based upon law of conservation of energy, and now because you have studied almost every basic of mechanics, so you should be able to figure out when to think about which law. 3 basic laws I've already told you. Okay, so if you try to solve this religiously, if this is the center of mass, then initially the center of mass is at a distance L by 2 from A, so that's the height, and finally it will come here, so its height will become 0. So initially the potential energy is the only energy, initial velocity is already given as 0, and finally when the rod will reach here, different points will have different linear velocities. Okay? Different points will have different linear velocities, but they will definitely have the same angular velocity. Okay, getting my point? So looks like there is only one option that is dimensionally correct. I did not pay attention to that. That's why I'm explaining the entire method. So loss in potential energy is equal to gain in kinetic energy. Potential energy is changing by mgl. Kinetic energy is half I omega square. I gave you the value of moment of inertia. Simplify that. Omega comes out to be under root of 3g by L. You'll be able to simplify this part, everyone. Simple calculations. M से M cancel करना, L से L cancel कर देना. 2 and 2 gets cancelled. Omega comes out to be root 3g by L. And what is the distance of this point from axis of rotation? What is the distance? You see that it is L. Correct? So what do we get? V equal to omega L. That's why under root of 3g by L into L. So यहाँ से 3g by L. That L which is outside, that comes inside, becomes root of L square. L and L gets cancelled. Answer becomes root 3gl. Okay? Understand, everybody? Great, awesome. Chalo, one more, quickly. Switching off the chart. A body rolls without slipping. The radius of gyration of the body about an axis passing through its center of mass is k. This is the radius of gyration. The radius of the body is r. You have to find out the ratio of rotational to translational kinetic energy. Giving you guys 90 seconds once again, and the time starts in 3, 2, and 1. You can assume V is equal to omega r. Okay? Not you can assume, it is given. It is rolling purely. It's pure rolling. So V is equal to omega r. 25 seconds remaining, everyone. Okay. Similar thing we have done already. So let's see. The answer is option A. Very easy. It is. Rotational kinetic energy is half I omega square. Translational is half mv square. You can write the moment of inertia as mk square. Omega is v square by r square. You can see that v square gets cancelled, m gets cancelled. You're left with k square by r square. That's it. Right? Okay. Hold on a second, please. And these were the homework questions. Okay. So these were our previous session homework question. So two bodies with moment of inertia I1 and I2 have the same angular momentum. If the kinetic energy of rotations are E1 and E2, then what do you think will be the relation here? So ये बहुत simply answer कर देना था. You know that kinetic energy and linear momentum are written like this. That linear momentum is 2 mk in under root. Can also be written like this. We all know this, right? So can I say angular momentum can be written as 2 into I into k, rotational kinetic energy? So they have different rotational kinetic energy. Rotational kinetic energy can be written as L square by 2I. So if they have the same angular momentum, they have different moment of inertia. The one which has more moment of inertia will have lesser energy, right, everyone? So if I1 is greater than I2, E1 should be less than E2. The answer should be option B. Correct. Now this one was a meter stick. Meter stick is basically a rod of length 1 meter. This says that it is pivoted about its center, and the piece of wax of 20 grams is traveling horizontally and perpendicular to it at 5 meters per second. It strikes and adheres. Adheres means what? Sticks. It sticks to one end of the rod so that the stick starts to rotate in a horizontal circle. So given the moment of inertia and the stick and the wax about the pivot is 0.02, the initial angular velocity of the stick will be how much? So this is a question from law of conservation of angular momentum, by the way. Yeah, it's also a homework question of previous class. So from this point, I can write the moment of inertia as mvd, and d ka value is this. Okay, it sticks to one of the end. So this is definitely half a meter where it sticks. So mass of the wax, velocity of the wax into point where it sticks, getting, and will be equal to I omega. Moment of inertia is already given, and question is asking us about omega. So one only correction. This should be 1 by 2 meters. That's it. Omega ka value you simplify, you'll get the value as 2.5 radians per second. This is law of conservation of angular momentum. Okay. So this is also the homework question of previous class. मजाक मजाक में आज हम लोगों ने 69 slides cover कर लिया. This is like very rare in our class, right? Harsh Katuria, this is that question only. सामने वही सवाल है, homework question. Okay. Okay, the leaderboard first of all. Congratulations, everyone. Well done. This is where we have completed, we can say, mechanics first stage. Entire mechanics 1 is done today. Okay. So can we do, now I'll be open to doubts obviously first. Okay, everyone. I know chemistry can go to 100 slides plus, yeah. How much is left as in the session is that way is over. Okay. Now I'm open to doubts, obviously. So can you show me the question of rod falling? I guess you're talking about this one. Okay, yes, exactly. Mechanics, we have gravitation. I'll not include in mechanics. After this, the next chapter is going to be gravitation. After that, when we resume mechanics, it's going to be simple harmonic motion and waves. Simple harmonic motion and waves and fluid mechanics. Okay. Mechanics 1 of Tattva, I do not know, but definitely mechanics 1 is done. I did not say that as per Tattva. First Tattva is already done, I think. First Tattva, mechanics 1 of Tattva is like way back done already. That was only the laws of motion. Okay. Class 12 does not have mechanics. Ab tak tumne jo bhi padha, everything is mechanics. Whatever you have studied in 11th is entirely mechanics. Okay. Okay, so I'll play just one song, then only one song. Yes. Can I go on full screen? Because I think many people can't see when I go on full screen. अरे गाना सोचने तो दो. Okay. Yeah, actually, there was a chord missing. Those who understand, they will understand this. This is actually for mechanics. So one more. That's it. And that's going to be the last one. I usually play this a lot. I used to play this a lot. For those who do not understand Hindi, this is for them. So lost, no matter how far, couldn't be much more from the heart. Forever trusting who we are, and nothing else matters. Trust I seek and I'm finding you. Every day for us something new. Open mind for a different view, and nothing else matters. This is what happens when you're out of practice. Okay. चलो अब जिनका सिर्फ गाना सुनने का मन था, they can leave. Thank you. Yeah. So that's it. बहुत दिनों बाद वहाँ से नीचे आया by the way for all of you. This doesn't come down more often nowadays, but yes, today this happened, and I'm glad that I kept my promise. I wear shorts in my class. Everybody knows that. Dream into mission impossible नहीं हो सकता. We have to. Sir, so you dance. If I dance only in someone's wedding, and that too with Bharat. So do you take class on Mac? No, I don't take class on Mac. I do have a Mac, but I do not. Will you dance for us? Definitely when the day will come. Probably not so soon. अब next stop आएगा जब पूरी 11th standard खत्म हो जाएगी. Next dancing तो you guys know when I will dance, right? But next guitar session will happen when the entire mechanics and entire thermodynamics will be done. Yes, definitely. That will be a rare occasion in itself. ठीक है, चलो guys. Thank you so much for helifying me and calling it a good singing and good guitaring. You guys are very good at line. That's really good. Thank you so much. Okay. चलो भाई, अब doubts वाली जनता. Officially by the way, the class is over now. Thank you so much for bearing me today. And those who do not have any doubt can definitely exit the session. Class teachers, thank you so much. Shubham sir, Anshul sir, Anil sir, thank you so much. Thank you. Yes, I'm glad that you guys were able to enjoy this. Okay, now people with doubts, come on, quickly, because then we all can wrap it up. Yes, Monish. So I have just a minute. Rubum says I have a test on 27th, having test on Vedanta on 26th. What should I do? Yeah, both are not overlapping. They are on different days. Appear for both of them. Okay. Yes, we are. Yes, you are. Moving batch वाला मतलब समझा नहीं. तुम बोल रहे हो नहीं ऐसा कोई सवाल डिस्कस नहीं किया ये वाला. ये हमने सवाल डिस्कस नहीं किया जिसमें भी talked about the condition that this block should remain at rest with respect to the triangular wedge. So there is only one condition that we are left to discuss then. So next class में मुझे remind कराना. ठीक है. It will take like 10 minutes only. It's a very simple situation. You'll understand. Independent of mechanics. मतलब वैसे basics of mechanics, law kinematics तो लगेंगी, laws of motion तो लगेंगी, पर as a chapter it is entirely different from the field of mechanics. बोल नहीं सकते entirely. रोटेशन भी आएगा क्योंकि अर्थ रोटेट करती है. हाँ तो समझ सकता है. अब मैं ये नहीं बोल सकता हूँ कि now it is independent of something. It is now entirely everything is dependent. Okay. But it is going to be very not entirely. You will feel like you're studying mechanics. It is going to be a little different. थोड़ा feel अलग होगा उस chapter का. ये बोल सकते हैं. Okay. Thank you so much. Okay, bye bye. Good night. Yes, my hometown is Kota. My father has been an army officer. Thank you for paying attention to a video. Now I'll speak to Monish. Yes, Monish. Good evening. Tell me. Yes, rod one. Just a minute. The one where rod was falling and we were supposed to calculate the velocity of this point, right? Tell me. Huh. For as in potential energy we can. Potential energy we can. But axis of rotation has to be at A. Because that is the point where the rod is falling. Means if we choose the point B as the point of potential energy, let me recommend choosing C as the point of potential energy. Point B. No, we can. So how will I do it? I will say that and I'll take it on a new slide altogether. Okay. So it doesn't change this at all. So we come here. Okay. So instead of calling this as h equal to 0, I will say point B is my h equal to 0. Okay. Now, where exactly is center of mass in the situation 1? It is at a depth L by 2. We can't because then different points have different potential energy. Then if I think about this point, the potential energy of that point is different. Potential energy of this point is different. Even if I consider this rod is made up of 4 masses, m by 4, m by 4, m by 4, still I can't solve it that way because different points are at different height. So I cannot write the potential energy there. For potential energy, I have to write the potential energy of center of mass. That was the whole logic of defining center of mass and studying it. That will not be correct. Okay, thank you. Okay, bye-bye, good night. So can we solve I1 greater than I2 question with half I omega square? Let me speak to this guy. Moni, good evening. Let me go to that question. You're talking about this one? Then what are you saying? Can we solve this by half I omega square? We can, but they don't have the same angular velocity. They have same angular momentum. Then you will have to find out the relation of angular velocity also. And it will become very difficult because then you would have got the expression. You must have done this. I1 omega 1 is equal to I2 omega 2, right? And you must have got I omega 1 by omega 2 equal to I2 by I1, correct? Right? And I1, correct? But if I write half I omega square, how will I know that I1 omega square 1 is greater than or less than just by knowing this? Why? Because 2 is less than 4 also, 2 is less than 7 also, 2 is less than 9 also. I do not know empirically that which of these factors is bigger. The moment of inertia factor being I1 greater than I2 is a bigger factor, or omega 1 being less than omega 2 is a bigger factor. Are you following what I'm saying? When I square, tell me. Let's go to the next page, new slide only, and talk about what you have done. Tell me, what do you want me to write it here? First of all, I1 is greater than I2, so definitely omega 1 is less than omega 2. Henceforth, what do you think we should do? Half into L into what this represents? Half I omega square. Then you can do it. Then you can do it. Then you can do it. Then your kinetic energy, basically you have to bring L into the picture in the formula. Then you have to bring L into the picture, definitely you have to. So now you know that omega 1 is less than omega 2 and K is directly proportional to omega, so definitely K1 is less than K2, correct? Getting? And I think that is the answer also. Yeah. I1 is less than A2. That's right. Okay? It's correct. But lengthy, as an unnecessary. Okay. Okay. Thank you, Abjo. Thank you. Good night, Bashar. Good night. Yes, Vidya. I'm trying. Yes. This one. Tell me. You can assume it to be in the backward direction also. It won't change anything. Will be equal to 0. But because friction is 0, so this plus or minus doesn't play any role. That's why. That's why logically we did not start with saying that friction will be in the forward or backward. We said let's assume that it is in forward or backward direction. You see that even in solution they have written let friction be in the forward direction. If they will take it in the backward direction, then they will just mathematically write it as capital F minus small f equal to mass into acceleration. That's it. Otherwise, nothing else is needed. Hmm. Get what? No. After you explain the body, what does it say? Hmm. If they will take it in the backward direction, then they will just mathematically write it as capital F minus small f equal to mass into acceleration. That's it. Otherwise, nothing else is needed. Hmm. Get what? No. After you explain the body, what does it say? Hmm. Surface is horizontal. Is it moving clockwise or anti-clockwise? Clockwise. Linear velocity here. It has not even given. It has not even given any velocity direction, I guess. It has not given any direction of b, right? So the body is rotating, right? So basically, you have done one thing. You have basically taken a ball. You have just rotated in air, and it falls on the ground. Okay. Once it falls on the ground, and it is a rough surface, I'm sure it must have mentioned it also. So look at the bottommost point P. Question is asking us for pure rolling, or it is just asking what will happen if it hits the ground. It will move. Okay. So you look at this point P. If body did not, by the time the body did not hit the bottommost the ground. So what is happening to point P? Can I say point P is moving like this? Other points are having their tangential velocity. Point P also has its tangential velocity. That is omega r, which is a pure rotation motion happening. Okay. Now what happens? The surface it touches. So when it touches the surface, what would surface try? Surface would not like this point to be moving backward. Why? Because of force of friction. So force of friction does not like the relative motion between the two surfaces. So what will force of friction try to do? It will try to stop it. So if it will try to stop it, in which direction it will act? Opposite to the direction of the velocity which it has. That means this is the direction of force of friction. And this will be kinetic, by the way, because it is sliding right now. So at this instant, the body will skid to the forward side. That means what? In this situation, the body is already rotating in clockwise direction, but the force which is acting on it is going to produce an anti-clockwise torque. Do you see that? That means what? The body will continue to rotate in clockwise sense, but it will slow down. Its angular acceleration will be anti-clockwise, like the one which we talked about today in the case when the body was slide and rolled up the plane. So this is going to be retardation. What are the options? Can you please read them? It goes like this. If I'm looking at it from the top, say if I'm looking at it from the top, okay. So this thing goes down, slips, center of mass gets a force forward. Look at the location of center of mass. Can I say center of mass is only experiencing force of friction? That means center of mass will go forward first. But after some time, the body will stop. Why is it stopping? Because the torque is trying to stop the body. The body will stop and will come back after that. Okay, that's it. Okay, bye. Good night. Sorry. Thank you. Thank you so much. Good night. Bye bye. Vishesh, your microphone is not working. And Vishesh, have you solved the entire tattva? Your microphone is not working. And the doubt is from which chapter? You're still stuck at 10 11, I guess. Microphone not working, Vishesh. Okay, I'm waiting. Anyone else apart from Vishesh having any doubt? Okay, Vishesh. Still not working, Vishesh. Okay, Nihal, no problem. Okay, Vishesh. Nihal, let's speak. Hi, Nihal. Good. Did you say chemistry? How about physics? How much you got in physics? How much? 32 out of 60? 62. That's not a bad score. That's not a bad score. I would not say it is an awesome score, but it is not a bad score. It's an average score. You know how much people get to qualify for JEE Main to JEE Advanced out of 300? Take a guess. I'll give you 3 guesses. That's your first one. Second guess. Third guess. 200. Yeah, so this is the nearest to your guess, and it is less than 100. And if you think that Suisa is just saying this just to make you feel good, after the session, just Google the cutoff marks for 2019, 2020, 2018, 2000, whatever. Okay, so earlier, till before last year, JEE used to be of 360 marks. From last year onwards, it has become 360, but you can always work out the percentage of the marks required to qualify, right? So never ever JEE cutoff has been more than 1/3 of the maximum marks. That's one thing you should always remember. But that does not mean that I should not try to get more than 1/3. That's why I said your score is decent. It is not amazing in physics at least. Chemistry again, not the right person to answer anything about it. Means I will not be able to help you. What should you do in order to improve chemistry? In physics, I can only say hang in there. Make sure that you are solving more questions rather than studying more theory. My words will remain the same. Try to correlate the theory that you study in physics with the problems that you solve. That means what? You should not every time go to the theory part of the chapter before you start solving the question. That means what? Say today you decide that I have a test coming up in NLM. I don't want you to actually spend an entire day in just reading the theory of NLM. I would rather recommend just go through the synopsis quickly. Okay, these are the formulas which are important here, and these are the basic points that are required, and then directly start solving the problems. Solving problems will actually help you recap the theory better, and obviously it will save your time, because if you will otherwise just study the theory and then solve the problem, you will end up solving lesser problems. You will be studying more of theory which is going to be irrelevant, because not much of theory will be asked even in your school examinations also for that matter. Exactly. In physics, they don't ask it. What about NLM? Uh, That's what I always say. That always be in sync with what is happening in the class. Try to always keep the understanding clear with what you are studying. Means when you always finish a chapter, you should have a one-pager summary of what has studied in the chapter. Always a one-pager. And those 3-star methods that I've always given you. You should always have your notes and your tattva books to be divided into 3-star categories, so that as per the time available, I can always revise it. So if I'm having lesser time and I want to just quickly brush up the entire chapter, I have my one-pager theory. I have the 3-star mark question. I'll just go through the 3-star mark question. I will be able to understand, or rather get a bird's eye view of the chapter once again whenever I need. You have to cover that chapter. At least for this, I cannot say that you can skip a chapter. 11th standard, I cannot say that. 12th maybe, but 11th no. If you miss one chapter, you're actually missing the entire physics after that. You have to find 1 day, 2 days in a week to cover that chapter. That should be your first priority. Whatever is your time, whatever is your speed of learning, it is dependent upon your speed of learning. So if you think you will require, say, 15 hours or 20 hours to study that chapter, you have to figure out how you find out those 15 hours, 20 hours in the time frame that is available, and then make sure that you are covering up that chapter or series of chapters. Okay. You should what? As you want to, whatever suits you best. I always said that you should try to find out and tailor make your own preparation. You cannot actually follow a fixed template which is working for someone else, will work definitely the same way for you. It doesn't. So you have, I just told you. I just told you in physics, simple formula, problem solving. Struggle through it. I would say struggle through it. Endless struggle, let it be, but don't give up. These are the only two things that I always say to my three aspects. One, problem solving more important than theory. Second, struggle through the problems as much as you can. You will not be able to solve the questions maybe after 5, 10 attempts also, but you will definitely make your brain think. And whatever you're thinking in those 5 attempts, 10 attempts, it will become applicable to some other problem, and you will definitely be able to solve the possibility in the future. Okay, so hang in there once again. Take care. All the best. What would you recommend for revision for old concepts, weekly or monthly? I would say when the test comes. Before that, you keep on revising, or whenever the requirement comes. I do not decide how that micro course comes, Vishesh. That is operational problem. I'm not the one who decides that. Okay. Okay, everyone. Let's call it a day here. We'll meet again on Wednesday. That is 22nd. Okay. Sure then, everyone. Bye bye. Good night. See you all on Wednesday. Take care. Yes. Hasta la vista.